Hello everyone. Today I want to show you how to make a physics experiment. What we need to do is to measure a speed, or not a speed, sorry, acceleration due to gravity. That's our goal. What we need for this experiment is a timer, stopwatch, timer, and a ball. Also, we need to measure the distance that the ball falls from the height, well, the distance the ball falls from, so the height practically, yeah. So the height is constant in our case. It's about 1.52 centimeters or 1.52 meters, so 152 centimeters, and the timer. So and then I'll show you how to do the rest. So what we need to do in this experiment is really try to measure as accurate as possible the time it takes for the ball to fall from this height down to the earth. So let's try this experiment. So it takes about 0.5 of a second for the ball to fall from this height, but we need to do the experiment several times to get the more accurate value. So we try to measure again and try to get it as accurate as possible. Oh, that takes about, this one was about 1 second. Strange, but well, see how inaccurate my timing is, my reaction time is. 0.5 of a second. Oh, this one 0.62 of a second. And same. So we need to repeat this experiment like that several times and measure the speed of a falling ball from the height, whatever the height you wanted to measure it from. So that's what practically needed. It's a really simple experiment, but you can use it in everyday life to calculate the acceleration due to gravity on Earth. And move on to the formulas now. So what we need now to do is, after we've done our experiments, what I did before actually on a video, I did use two balls to measure the time, but I actually went and redid the experiment just with one ball and tried to get as much accurate values as I could for timing. And I repeated the experiments several times so I can get the average value of our calculated um, acceleration due to gravity. So many times I did the maybe 5-6 times throw the ball down and measure the time, which was different all the time, just with one ball. So but you get the principle. You just use one ball and you the distance, and you measure the time and so on. So what we need now is to calculate the time, calculate the acceleration from what we have from my equation. What we need to do is use equation 3, where x is the distance traveled, v naught is the initial velocity, which in our case is 0. The ball falls from rest. So this term, we don't need it, disappears. So what we need is just this term here, half of at squared, and a is our acceleration that we want to calculate. So rearranging this equation gives us a formula which is 2 times x divided by t squared. We're going to our Excel sheet, and we put all the values for time. So this is the time. This is the time takes in seconds. So this is the distance in meters. So it's 1.52 meters, and this is time in seconds it takes for the ball to fall from that height. And what we get is acceleration. Every time is different, but I got the average value here. So here's the formula if you want to have a look. 2 times a times b 3, and then I summed all that up and divided by 5. 1 2 3 4 5, and I get this value here, 9.6 meters per second. That's our estimated calculated estimated value for acceleration due to gravity. And now we can go on online and have a look what is the value of acceleration due to gravity as as a constant, as a measured value, as a constant measured value that is um, we can just confirm. So see, as you can see here, g, it's called g, not acceleration, but yeah, acceleration is gravity, but it's determined as g, not a, and it's 9.8 meters per second downwards, so falling towards the earth. So as you can see from our calculation, the average value is 9.6. Obviously we have errors. This is exact value. This is what been measured, and it's a standard acceleration due to gravity on earth. On moon it would be different, but in our case we have 9.6 meters per second, 9.609, etc. But 9.6, this is pretty close to what we have, um, as a standard value. So the experiment is pretty simple, straightforward. You just take the ball, measure it a few times. You can try with different balls, and also what you can do. Also, you can try different heights. What you can do is set up a chart. What you can do is set up not just one height, but you can take a different heights, let's say 1 meter, 2 meters, 3 meters, 4 and 5, let's say, and then you can measure the time it takes falling from the 5 meters, 4 meters, 2 meters, 1 meters, and etc. And obviously that's it. And what you can do, you can plot. Then you can take all these values, whatever you have, because you have different heights. You can plot against the time. You take an average time. You measure it a few times. Let's say you measure time 5 times from falling from 5 meters, 5 times from 4, and etc. And you can measure. You can get the average time, and then you can set up a chart, and then you can plot the graph. You make a graph and plot and get the slope of the graph. If you know what I'm talking about, the slope of the graph, you plot a chart, time at the bottom, again x versus time, and then you have a plot. You plot all these points and get an average gradient, not average, but you get a line, which is you do regression, you get a line, and then you get a slope of that line, which will be your acceleration. So you do regression on those values, and you will get yeah, that closest value of even closer than this what we have here. Should be closer, but depends on your experiment, how well you've done it and how accurate is your numbers. Because for me, obviously, you can see that the time it takes for the ball to fall, it wasn't pretty accurate. Sometimes it's more and sometimes it was less, and this is the closest. I try to concentrate and press the button right at exact time when the ball falls, touch the ground, and I came up with these values. But and plus I don't think my recording timer was very good either, so there was a lot of errors. But yeah, got close enough. Got close enough. So you get the idea. So this is how you measure the acceleration due to gravity, and you can use this physics experiment for your high school, for your year 12 projects and stuff, high school projects, and yeah, and enjoy. And thank you very much. And goodbye.